Welcome everyone. Today we're going to do a quick deep dive into serverless workflows. These slides and other resources will all be available via a link at the end, so don't worry about trying to screen cap everything. I'm Scott Blake. I'm a client platform engineer at Flywire. I've been here for about a year. Before that, I worked in higher ed for about 20 years. I've been managing Apple devices since the days of Leopard and Snow Leopard. And if you're looking for me on the internet, I'm at @MScottBlake on most sites. You can take notes if you want, or don't if you want, that's fine. I've uploaded a copy of these slides and the scripts that I'm going to reference to my GitHub repo. So if you want to follow along, the link is right here. This slide will appear again at the end, so don't worry if you didn't get it in time. All right, so a quick overview of what we're going to talk about here is, first of all, why do we care about serverless? Kind of go through some of the quick ins and outs of a local environment. Talk real quick about some of the common services within service. And then most of this time is going to be talking about some examples, some real world examples of code that I've written and used in my time doing this stuff. So let's start off with a simple question. Why do we care about serverless? So the biggest thing is, we want to get rid of this type of environment. So, if you have a computer that runs automated scripts from a network closet or, a corner in office or something like that, do me a favor and type a 1 in chat. If you have scripts on your local computer that you run occasionally, type a 2 in chat. I'm going to assume that since you're here listening to this, that, there's a fair number of 1s and 2s. So, hit the wrong button. So back to that question, of why do we care? So most people don't have backups of scripts that they run in environments like this. In my experience, it's common that only one person fully knows what that does. And, there are often computers with, auto login enabled, and, they're not patched like other computers, leaving them more vulnerable. Hardware, frankly, is expensive. It's expensive to buy, it's expensive to maintain, and it takes time to keep things patched since you've got to do it manually. So in essence, the goal of this talk is to take you from this to this. We want repeatable code. We want it stored in a central location. And, with serverless, it can, it only costs money when it's running. So if you've got cron jobs and things like that, you don't have to pay money for, the other 99.9% of your day. So there are many ways to achieve this. I'm going to walk through an example with AWS and the Jamf Pro Classic API. But these concepts are certainly not limited to either of those. Azure, Google, others, they all have similar services. And you can really apply these concepts to any vendor API. To get there, we need to talk about a baseline local environment. So the AWS CLI, command line interface, is so powerful that I could probably spend an entire session talking about that. But I wanted to give some examples instead. So, one of the most useful parameters it accepts is the profile flag. So this allows you to easily take the same command and declare it to be run against a completely different environment or even a different account. So to configure your different profiles, you will be modifying these 2 files. You will definitely have a config file, but depending on your environment, you may not need a credentials file. Each environment is different, and I suggest that you read the AWS documentation to get a better idea of what's needed, but I'll show some examples. They are nowhere near the full capabilities. The most basic AWS credentials are an access key ID and a secret access key. These are comparable to a username and password. These fields can go into a credentials file as shown, and you'll notice that in my example, the default is the same as dev. This isn't necessary, but it means that I don't have to type -- profile on every dev iteration of a command. It also helps me protect me from doing things in prod. Now, I don't have to have dev in this situation, but personally, I like to be explicit when I can. So if I'm running things in dev, I want to tell it dev. If I'm running in prod, I need to tell it prod. But if I forget that, I don't want to be messing up prod. The config file is way more powerful. The data stored in this file serves as a default. You can override the fields within each of your commands, but if you don't include them in those commands, this is where it looks. You'll notice that the headers contain the word profile in them, whereas the credentials file does not use that keyword. If your organization uses SSO, those settings go into the config file. It's a little counterintuitive. And this example shows that you can not only define different regions, but you can also define entirely different accounts and roles. I use different profile names, but you can and will use the same names in your credentials and your config files. And by that, I mean like dev and dev SSO oftentimes would just be dev. I just highlighted them differently here. Signing into SSO is not difficult once it's configured. If you were to run both of these commands, signing into prod will create a secondary set of credentials. It does not override dev. You end up being logged into both at the same time, and then you just use the profile flag to define which environment you are trying to run a command against. The SAM CLI, SAM stands for Serverless Access Model, has quite a few commands, but the three that are most common are verify, build, and deploy. The verify command makes sure that your template is valid, essentially lints your file. The build command takes your code and puts it into a deployable format. And this is something that you have to do for every time you make changes. And then the deploy command is the one that you use to push your changes to AWS. So if you have a change, you need to build and then deploy, make your changes, build, deploy, make your changes, etc. The first time you deploy to each profile, you'll need to use the -- guided parameter. This will prompt you for more information, and then it will save those answers to a local TOML file. Subsequent runs will pull values from that file, so you don't need it to be guided every time you want to deploy. If you need to make changes, you can just change the field within that TOML file, or you can just run guided again and it'll ask you all the questions and you just answer them all at once. So moving on to some common services. For the purposes of this talk, we're mainly talking about Lambdas. The Lambda service allows you to run code in the cloud without having to worry about the server that is running on it all. You're only charged during runtime. So if your script takes 5 seconds to run, you get charged for 5 seconds. That's it. If you compare that to a computer in the corner, where you're paying for electricity, hardware refreshes, and all the like. S3 gives us a place to store the code. SQS and SNS are services that we can use to communicate between Lambda and other services. They're messaging protocols. SQS is a queue, and it ensures the messages are handled, whereas SNS is a notification, or put another way, messaging via UDP. There's no guarantee that an SNS message has made it. You know, depending on your situation, each different thing is useful. You may care that, something gets the message in one situation, you may not for another. Additionally, here are some of the other services that we'll kind of touch on. Some of these are configured automatically. They're useful to know, but they may not be crucial to know in depth. For instance, VPC, or Virtual Private Cloud, is like a VLAN, and it lets you isolate your infrastructure. You can use IAM, or the Identity and Access Management, to grant access to Secrets Manager, which in turn uses KMS to secure its secrets, and that stands for the Key Management Service. So, let's head into a few examples. The first being a simple Lambda. It sends a message to a Microsoft Teams channel. And this one is triggered automatically whenever a message appears in a specific SQS queue. This one specifically will take a message that comes to SQS and put it in a Teams channel. So here's the folder structure for this project. There's a template file in the root of the directory. This file is written in the AWS Serverless Application Model Syntax, or SAM. There is also a folder containing the Lambda's code. That's a Python script and a corresponding requirements file. That's all there is to make this one work. Of course, any good project needs a good README as well, but I am not going to go into that. Here's the template YAML file. The AWS template format version is optional, but this field identifies the capabilities of this template. This is similar to a V1 in an API call. The transform key, however, defines a macro that's used to transform this template into a compliant CloudFormation template, which is the basis of what SAM is built on. And I'm not going to get into any of the details of that, but this extends the CloudFormation service. Within the resources section, we define the AWS resources used in this stack. Here, we have a Lambda being defined. This is the name that we're giving the resource. And here we're defining the environment to use. In this case, it's running Python 3.8. And then when it runs, it looks in the source directory for its code. If it finds that directory, it will call the Lambda handler function within the index file. And you can see how that is structured there. You got the file.function name. The code is triggered on this event. We give it an arbitrary name, in this case, SQS event, because we can have multiple events in this. We can have the same Lambda triggered by multiple different sources. This line designates the specific SQS queue that we want to use. And here we are using a SAM template shortcut to get the Amazon resource name, or ARN, of the specific queue that we want. This attribute the ARN is globally unique within AWS, so we don't have to worry about duplicates or anything like that. Next, we configure an SQS queue and we name it. You'll notice that this is the same name referenced in the Lambda, so SQS send to teams. There are tons of other configuration options for both of these different resources. These are just the requirements to make this workflow work. Finally, we get into a section that is not covered in many tutorials. But let's say that you have other code somewhere that's outside of this stack, and you want to reference this SQS queue. This is how you can expose some fields to do so. So this output exposes a name and a URL that we can then use to add messages for processing by this Lambda. I will talk a little bit more about this later. This is just the receiving end of that. And here's the index file for that. Before we get into the script itself, though, I wanted to call out that one thing that helps me a lot is that I like to document the expected format within the comments if we're getting data in. I find it easier to comprehend what a script is doing when I know what the input looks like, very specifically. There's not much to this script. It takes a group of queued messages as input, loops over each message, and then sends it to the designated webhook URL. Each team's channel uses a different URL, so that is part of the message that gets input into it. This makes the script more generic, and it means that we don't have to duplicate this stack for every channel we want to send a Teams message to. We can have one stack for all channels. Now, you'll note that this is a function named Lambda handler in here. This matches that template that we just talked about, and therefore, this is the function that will be called when the script is invoked. We can add more functions without worrying about the starting point at all. So that's why this becomes really super helpful. Our next example is a little bit more complex, though. It is triggered on a schedule, and it gets a list of computers from a Jamf Pro advanced search. It takes that list of devices from the advanced search, and it puts each of them into a queue, which triggers another Lambda to unmanage the computer. You can think of this as a one-to-many relationship. In fact, when the Lambda completes, it sends a message to Teams by sending a message to that SQS queue that we talked about earlier. As you can see, though, that this can get pretty complex pretty quick. The cool thing is that the structure of this stack isn't really any more complex than the first, though. So as you can see, we have an extra Python file inside the source directory, but other than that, this project looks the same. So let's dig into the template again, but I'm going to pick up the pace a little bit, but I still want to highlight some of the key differences. So here we are with the template. Right away, you'll see that there's a new parameters section. This is a way for you to add variables into your templates. In this case, group name takes the string name of an advanced search from Jamf Pro. So this lets Jamf Pro do all the heavy lifting with its inventory without adding the overhead of a smart group. So an advanced search only uses resources when it's called, whereas a smart group performs it on every inventory. So you'll notice that this section is the same as the last example. It will look at the source directory for a file called index, and then call the Lambda handler function within a Python 3.8 runtime. And then this is how you get the template parameters into a serverless resource. The ref function is a shortcut that references an element. Similarly, the sub function is a parameter. It's used to place a variable into a string. Parameter substitution, I guess, is probably what it's shortcut for. The policies section configures IAM, or identity and access management policies. In this example, we are granting Lambda the ability to read values from the parameter store, as well as the ability to send a message to the SQS queue. Secrets Manager can be used here instead of the parameter store. They have very similar features. The parameter store and Secrets Manager can both do hidden secrets, but the parameter store can also do unhidden secrets, so just regular parameters. It just so happens that when I wrote this stack, I used the parameter store. probably should be secrets manager though for some of this stuff. By the time you're seeing this, I may have both examples in the resources. If I don't and you want to see them, please ask. The previous Lambda example used an SQS event to trigger, whereas this one uses a schedule event. There are two different ways to describe a schedule. You can use rate or cron. And I'll have a link at the end for more information on both of those options. They're way too complex to try and drill down and describe in here, but the documentation for those is pretty great. Now this Lambda is slightly different. It is calling a function in the unmanaged Python file instead of index. Now you'll notice that this Lambda in particular is the unmanaged one. So this is that second Lambda in the workflow. In the first example, we exposed a couple values with the output property. To access those values, you use the import value function. The script needs the URL to send the messages, but we also need the name to grant the permissions to the Lambda so that we can actually send those messages. So that's why we had two outputs. All right, so moving on to index Python. All right, so one of the first things the script does is it pulls secrets from the parameter store. Like I said earlier, this can and probably should be done with Secrets Manager instead. The way you do this is very similar. The values that you see here are the stored names of the parameters in AWS. So in my environment, there's a /prod /Jamf Pro /address. And that's where I store the address of our Jamf Pro server. That way I don't have to pass it in or anything like that. It's just stored in the parameter store and the script can pull it as needed. So AWS provides a Python module called Boto3 that makes interacting with AWS services quite easy. Here we have a helper function that pulls a value given a parameter name. If we got our policies correct in the template, these integrations should just work. After doing some error checking, it queries the Jamf Pro Classic API, and then it parses those results. It then loops over each ID and sends a message to the defined SQS queue. Let's take a look at those functions as well. The Jamf Pro Classic API integration relies on the values from the secrets to make the connection. But this is a way to keep those values secure. They're never exposed and you don't have to pass them in, anything like that. So otherwise, this function is pretty standard stuff. So, when you're working with a vendor API, you set some headers, you define your URL, and you invoke the requests module to perform the curl command, essentially. Similarly, when we have a computer ID that needs to be unmanaged, we just send it as a message to the SQS, and then that triggers another script to actually perform it. This is where the one-to-many thing comes in. So let's, check out unmanaged. This file is mostly the same stuff, but there are a couple helper functions to facilitate API GET and PUT requests. And I did this because I had more than one thing doing those requests, so I made some helper functions for them. This is mostly done because of the error handling, and then it gives me some consistent returns for every single request. It means that most of the rest of the script is just formatting the data and then calling those helper functions. So the unmanaged computer by ID function, it defines the XML necessary to unmanage a computer in Jamf Pro. It takes a computer ID as the input, and then it sends that XML to the API. If it fails, it doesn't send a message to Teams. Okay, so Our third example is a little bit different. Have you ever wanted to run a report in Jamf Pro, but it wasn't quite able to do what you needed? For me, I had a situation where I needed to share a report with my security team. But the data needed to be split out by Jamf Pro site. Now, in Jamf Pro, the site field isn't something that you can add to a scope. So I had to script a solution. I could have just run the script on my local computer, but then no one else would know that it existed or how to update it or anything like that. So I made a serverless stack to run it for me. Like I said, this one is a little bit different from the others in that it contains an SNS queue instead of SQS, because I didn't necessarily care if they got it. This should start looking pretty familiar by now. There are certainly times where you'll need more files, but most MacAdmin tasks tend to be small. So this is what most of my stacks tend to look like. They're pretty generic. So let's start with the template again. You'll notice that this is pretty short. Most everything in here has been covered in previous examples except the SNS portions. This little section within policies makes sure that the Lambda can send those messages to the SNS. And you just got to make sure that it matches this field. This is the name of the resource for the SNS topic. You can create an empty SNS topic like you do for SQS, but then those messages won't go anywhere. So you need to add subscriptions. Now these could be emails like you see here, but they could be HTTP addresses like webhooks. It could be an SQS queue. So you go to SNS and then SQS. It could be a Lambda, or there's other options as well. And you can mix and match according to your needs. So moving on to the index file for this. I like to think that this script is pretty cool. Like I said earlier, Jamf Pro couldn't do what I wanted and split it by sites, so I created an advanced search that had all of that data that I needed except for the site. So this script gets all of the sites from the Jamf Pro Classic API. It does it in XML because sometimes you need to use XML, and I wanted to show some sample code of doing just that. It then loops through each site and it calls this function. It changes the site ID on a specific advanced search that I created. It gets the number of computers returned, and then it moves on to the next site. It changes the site ID, gets the number of computers returned, and moves on to the next site. Afterwards, it compiles all of those values into an ASCII table and sends the data to SNS. And like I said, our subscriptions were emails, so it sends an email with that. But then after that, it sets the site ID back to the global context so that my site admins cannot mess with it. And this is where it's setting the site back. I could have gotten more fancy with this one, but it got the job done. I could have also sent this data to Teams, or I could have used Amazon's simple email service to send HTML messages instead. Sometimes simple is better, and I wanted to highlight that it's not that hard to get something like this into the cloud. Here we have some AWS CLI resources, some SAM resources, some Bodo 3 resources, and then some others on top of that. And here's a link to the resources I promised earlier. Hopefully you found at least some of this information helpful. I really wish I had more time to dive into some of this. If there's anything in particular that you'd like to see me talk about in more detail next year, please let me know. Thank you for listening, and thank you to Jamf, particularly, for putting this together this great conference.